Mike, how often do you think about the sun?
I mean, not more than most, I guess. I know that the sun is a mass of incandescent gas, a gigantic nuclear furnace, where hydrogen is built into helium at a temperature of 1,000,000 degrees.
Oh, boy.
Yo-ho, it's hot. The sun is not a place where we could live, but here on Earth, there'd be no life without the light it gives.
Wow.
I'm a scientist now. I listened to one song by There Might Be Giants, and now I'm a scientist. That's how it works. I think I also watched the Kirk video, and I'm done. I am like an absolute sun expert now.
They probably called something different than sun expert.
No, I don't know. It could be anything. Anyway, what are we talking about today?
A sun ties scientist.
No, it's not good. What are we talking about today? I tried to do that too. It's not a good pun. There isn't a good pun of mixing sun and scientist. I tried it. You tried it. We failed.
I'm sorry. I'm not bright enough. Today we are talking about geomagnetic storms, and one in particular, the Carrington event, which took place in 1859.
So before we actually talk about the Carrington event, I guess we have to talk a little bit about how the sun works, right?
We do. A little bit. If you want to hear me talk a lot about the sun with my friend Jason Snell, check out episode 6 of my space podcast called Liftoff. Link is in the show notes.
That is vertical integration.
It is.
In action.
It is. Because the sun is above us. It's not really above us. It just looks that way to us because we are tiny ants in the solar system. Okay, so the sun burns hydrogen, and as it does so, intense heat and pressure are created. The middle of the sun is not a place that you would want to be. You wouldn't want to find yourself there because it's a terrible place. So energy is dispersed up through the star's layers, rolling up onto its surface. Sometimes large amounts of plasma erupt out from the surface, twisted by the sun's magnetic field. These are known as coronal mass ejections, or CMEs.
CMEs often fall back into the sun, unable to escape its pretty strong gravitational pull. But on the occasion that there's enough energy behind them, the plasma is pushed out with such force that it travels out into the solar system beyond.
Thankfully, the solar system is a pretty big place, so the chances of one of those hitting Earth is remarkably low. If you think about it, we're not only orbiting the sun, but these CMEs can come out in any direction, not just the plane that our orbit is in. Mm-hmm. However, it does happen. The largest of those events ever recorded is our main topic today, but let's talk a little bit about how CMEs interact with our planet.
The Earth is protected from all sorts of radiation, and the stream of particles always coming from the sun by the planet's magnetosphere, a protective envelope created by the Earth's magnetic field. Most of the time, the solar wind, that stream of charged particles, is easily managed by the magnetosphere, which directs the majority of them around the Earth, right? So it just misses us, goes around like an aerodynamic thing. You know, you put something in a wind tunnel,
sure,
and you can watch that. It kind of looks like that, I guess. This protective envelope isn't a hard wall. Some solar wind particles make it past, interacting with the upper levels of the atmosphere, creating auroras.
In a sense, they're just byproducts of tiny particles crashing into us, creating light as they stream past and interact with the planet. Look, the solar system is an amazing place, right? Like, it's super cool.
As amazing as the magnetosphere is, it can be overwhelmed with a direct hit by a CME. This results in what is known as a geomagnetic storm. The increase in particles from the sun hitting the outer reaches of the magnetosphere will compress it, allowing more energy through to the atmosphere than normal.
And that's when things get weird. So we're going to take a trip back to 1859 to see what life was like when the CME hit the Earth.
This is the Carrington event, named for British astronomers Richard C. Carrington and Richard Hodgson, who recorded the initial solar flare and helped document the CME and its damage.
I kind of feel like one of these guys got the short end of the naming stick there. Like two people, but it's only named after one.
Well, it's called the Carrington event after Richard Carrington.
Yeah.
But the other guy's name's Richard Hodgson, so why didn't you call it the Richard event? They're both named Richard.
Oh, that's good.
But one of them it's really mean. Very mean.
The CME that hit the Earth in September of that year took just 17.6 hours to cross the 93 million mile chasm between us and the sun. Most CMEs take several days to arrive to Earth, but this particular one followed another CME just a few days before it, which is perhaps why it was able to travel more quickly.
As the charged particles slammed into the magnetosphere, things got really weird on the ground super fast. According to reports, auroras could be seen nearly to the equator, with the light being so bright in some places that people were tricked into believing it was daytime.
Can you imagine, like, if you live in, the southern United States, southern Europe, Central America, someplace like that, and you're seeing these? Like, it would be, I think it'd be upsetting. It'd be scary.
Especially in 1859. Right?
Yeah, you can't get on Twitter and see what's going on. Telegraph systems were also just wrecked by the burst. Some telegraph operators reported receiving electric shocks from their equipment as telegraph lines threw sparks and even burned up across places in North America and Europe. For those operators still somehow connected to working lines, they could send and receive messages without the use of electricity.
That is unsettling.
It's spooky. It's not good.
Don't want that to happen today. All right, things would get really bad, right? If something like that happened today.
Yeah, we need our telegraph lines more than ever.
We sure do.
We almost found out how bad, because in 2012, a large CME missed us by a margin of just 9 days.
That seems like a pretty close call in the scale of the solar system.
It is. And while I've been lucky so far, there are some pretty good ideas as to what would happen to our 21st century way of life if we sustained a direct hit from a large CME. There could be serious damage to electric grids around the world. While governments have been working to increase capacity and protection for critical grid equipment, it's possible that widespread blackouts could occur, taking weeks or even months to repair in some remote areas.
Internet service providers could also see widespread disruption, as could military systems relying on high frequencies for radio communication. The fate of communication satellites, including GPS, could also be pretty bleak, as the charged particles could wreak havoc on their electronics and communications.
It's actually worse than that for satellites. So as the CME material hit the atmosphere, the upper levels would heat up, making it expand into low Earth orbit. And if that expansion were great enough, it would cause additional drag on these satellites, causing them to slow down and even re-enter the atmosphere prematurely.
Any astronauts in orbit would be in danger of receiving potentially fatal doses of radiation, but people on the ground shouldn't see an increased rate of cancers due to the event.
I mean, that's good for those of us who aren't astronauts, but pretty bleak for those who are.
Yes, they're probably not listening to this show, though, so they're not going to know about it.
Wait, they don't listen to this on the International Space Station?
I don't know. Maybe they do Liftoff, your space podcast, but probably not this one.
Maybe I should talk about the Winter Olympics on Liftoff.
Maybe you should. Go get your propaganda out there somewhere.
Wow. There are lots of animals that detect the Earth's magnetic poles and use that information for things like migration, and they could end up confused or worse for some time after the event.
This is terrible.
Well,
I hate this one.
It's 2020, so it probably won't happen anytime soon.
Why would you do that?
I'd like to thank Ronnie for suggesting this topic.
I don't thank Ronnie for this.
Wow, poor Ronnie.
Don't bum me out, Ronnie.
If you want to find links to the stuff we spoke about, head on over to the website, relay.fm/liftoff/110. While you're there, you can become a member to support the show directly. You can send us an email with your favorite weird Wikipedia topic, and it will go on the list. If that's too old-fashioned for you, you can find us on Twitter. The show is @Ungeniused. Mike is there as IMYKE, and you can follow me on Twitter as ISMH. And until our next ghost telegraph machine, Mike, say goodbye.
Goodbye.
Bye, y'all.